AQUABIZ, all the best knowledge for aquatic system.
So I have two presentations, and the first one is going to be on sustainability. And I really prepared this presentation almost for myself in order to better understand the field, because I work in this field, but there's a lot of abbreviation, a lot of concept I didn't quite get, and sit on a lot of meetings and people will say ESG and this and that, and I didn't quite understand. So it helped me walk through the process. So hopefully it can help you also better understanding. But in the end, right, understanding a field is one thing, doing something about it is another thing, so I'll try to give you some potential solution to improve the environmental sustainability of your feed. Basically, what is environmental sustainability? So, right, everybody's talking about it. It's on everybody's mind and everybody's lips, right? Environmental sustainability. Every publication you read from every kind of stakeholder of the industry, from the ingredient suppliers to the seafood distributor to the certification bodies or agencies are talking about it. So, what does it mean, right? What does it entail? Things. From an aquaculture feed manufacturing perspective, what is specific about it? What we're looking at? What are some of the high profile, more or less, effort that are being led? And what's some of the strategy at the end, what we can do to improve the sustainability of the feed? Now, why we're doing this is because we're in a changing world. I think it's pretty evident, unless you live under a rock, that the climate is changing. We're experiencing record temperature. We're experiencing change. I visit here quite often. I go to Ecuador. People are telling me the weather is changing. This month shouldn't be raining. This month should be cooler. This month should be, right? The temperature should be different. So things are changing on this planet. There's a lot of things changing. Temperature have been increasing, and it's pretty clear that it's associated with human activity. Even though there may be 10% of the people that don't accept this reality, it is a fact. And it's not going to get any better. I think it's going to accelerate. There are traps, there's reserves of methane being trapped in the Arctic and Antarctic and the oceans, very cold water oceans. There are solid traps of methane, and those, as the climate is warming, are going to be released even faster, and it's going to create more and more problems. So I think we're in an acceleration phase, in my opinion. I'm not an expert, but things are not going to get better, that's for sure. And we're seeing the consequence today, and imagine in a couple years, in 10 years, 20 years from now, and don't look right forward for the kids living in this environment. Even here in Southeast Asia, the Tonle Sap, the water levels, it's pretty good evidence that is going down by a meter or two, which is very significant for the livelihood, not just of people of Cambodia, but also downstream in the Mekong Delta. If you go in South America, they're experiencing change. The glaciers are melting. They're smaller than they've ever been. And there's other issue, talking El Nino is a natural phenomenon, but there's evidence that pollution is causing problem, and is causing problem for the aquaculture industry. 4 or 5 years ago, there was a problem in Chile, and it caused 4,000 tons of salmon to die like this in couple regions. So this can be critical for aquaculture also. So we're going to be on the receiving end of a lot of those problems, because we're dealing with animal in water. If the water warms up, right? We're also dealing with animal in water. If the environments become worse, then the animal will suffer. So we need to become more sustainable in our practice, right? The whole globe, the whole industry, the whole planet needs to become more sustainable. But what is sustainability? And the Brundtland Commission was put together by the United Nations in 1987 and came out with a definition of what is sustainable. So it's something, right, that meets the need of the present, but also consider the needs of future generation. So it's basically being good steward, right, of the future, right, while taking care of the people in the present. Now, sustainability applies to the environment. We always talk about environmental sustainability, and maybe we should be talking about environmental stewardship, right? Being good steward, being good caretaker of the environment because it's more active. But it's also economical, right? You have to maintain a viability of the economic and the conditions of people. And it also has to take into account, it takes into account societal, right? We're doing this for the people, taking into account the people, the belief of the people, the needs of the people, of the generation, the coming things. So sustainability is not just about environment, albeit it's one of the central piece, but it also has to consider economy, or it's not going to be, right, not going to be accepted, and social consideration. Now, we often hear the term ESG, especially if you deal in the corporate world and investment world like I'm starting to do. You always hear our ESG strategy and this, so I always kind of confuse between sustainability and ESG. The ESG is kind of a set of criteria that an organization, a corporation will set in order to achieve, right, certain goals, and that relates to, these goals relate to sustainability. So it's more of a process or kind of a roadmap or kind of a credo. Say, here's is what we're going to do. Here's are the steps we're taking to do to achieve this. The sustainability is the goal themselves, right? So what you want to aim in the end is to be sustainable or improve your sustainability. So it's your goal and target or the outcome that you're targeting. So there's two kind of separate things. Of course, they're highly related, but they're two separate terms. Now, recently, surveys have been carried out of corporations and organizations, especially corporations, and see why do you have like an ESG, or why would you be interested in having an ESG? And it's kind of fairly well distributed. The first one is say, well, we need to meet the client request. Our clients are asking us for this, right? We're selling shrimp to Walmart, right, Tesco or something, and they're asking that we're certified, they're asking that we're being environmentally sustainable. So it's not something we strive for, but we have to because our clients are asking for, right? Other one says, well, we want to make the world a better place. And they only had one choice, right? So of course it's going to be several choices, but right, the second group of user or people say, well, we want to make the world a better place, so that's why we're doing this. Other people say we want to become more efficient, and it's part of, right? It's part of becoming more efficient at using the resource better, so it makes economical sense, and so on and so forth. We have peer pressure. My competitor is using it, is doing it, so I have to do it and stuff. So there's different reason for that, but basically, right, boiled down to two things. Well, the society or the industry is demanding it, or we want to make the world a better place, and those are not like incompatible with one another. So environmental sustainability, right, refers to the goal that you want to achieve in order, right, to fulfill the need of the future generation while taking care, right, of the present. I like to use the term, right, to say, well, this is the kind of the goal, and the active process is managing environmental impact, right? What you can do. You cannot just say, well, I'm going to be sustainable or something. You have to set up a process. You have to set up certain goal. So I like to call it environmental impact management, or you can use stewardship, right? The practice that makes you a good caretaker of the environment is what you want to do. So it's about reducing emissions. It's about reducing waste output of compounds that can affect the environment. It's about conserving natural resource, whether biotic or abiotic. So whether, right, fish in the ocean, wild fish in the ocean, or minerals that you dig in the earth in order to meet your need. Now, environmental sustainability goals and objectives are part, right, of these bigger effort of the sustainability to improve, right, the livelihood of people, social conditions of people, economical conditions, and etc., the health of people. So the United Nations in 2002, I believe, established a series of goals, right, 17 goals in order to do this, and you can identify several of them relate to environmental sustainability or have a very strong environmental sustainability component to them. So this is weaved in a lot of different types of effort out there, right? That environmental sustainability is not just stand on its own. It's part of a bigger global effort to make things better for society. Now, something I didn't quite understand, that's why I said I prepared this presentation for myself. When we talk about environmental sustainability, I kind of always boil down to greenhouse gas emission, right? CO2 production or methane, and then waste output, right? Don't release the waste, solid waste, and nitrogen and phosphorus waste I'm using. But I was talking to people, they were showing things about acidification potential and depletion of this, of biotic resource and photochemical ozone formation and ecotoxicity and land use change, etc. All these things. So actually, the parameters, the indicators, the criteria, whatever you're using to measure environmental sustainability are very diverse because the environment is very complex. Right? So you can damage, you can change or improve the environment in many different ways. So there's not just one measure. So even though we boil down things very often to one or two parameters, greenhouse gas emission, right, CO2 equivalent, or waste output, it's a lot more complex than this. And proper assessment of environmental sustainability of a feed, of a practice, should encompass many of those considerations. I had a couple of calls with WWF, the team at WWF in Washington, D.C., and they're developing this ESG feed ingredient risk tool. They're mostly driving it or testing it with the salmon industry, the Global Salmon Initiative, I believe, that they're working very closely with, the big corporations that make up the salmon feed and the salmon producers. And they're testing this. And as part of their process, they're using a lot of these criteria that I just showed you before in their assessment. So they have a big, long questionnaire, I guess, or tool, or a bit of automatized tools in order to determine the risk of different ingredients on the environment, but also on the economy, on the people, on labor practice, and so on and so forth. Like you're probably very familiar with a lot of the certification program, the type of questions they're asking. And I went in their tool, so they shared their big spreadsheet with me, and I couldn't take the whole snapshot, but I took a small snapshot of it, like owning on a couple parts, and you can see there's one on pollution. What is the potential for polluting fresh water? And they're expressing this in kilograms of phosphorus output. Why? Is because the belief is that in fresh water, the most limiting nutrients for the growth of algae and therefore eutrophication is phosphorus. Not necessarily true, right? But I work with environmental scientists in freshwater. It's not necessarily true, and not just phosphorus. But it simplifies things. You can boil it down to one value, so it makes things a little bit simpler. In a marine or brackish environment, they focus on nitrogen waste output because it is, in general, the limiting factor for the growth of algae in a marine environment or brackish water environment. Not necessarily true again, but something. Well, I'll show you, I've done work on this, on managing phosphorus and nitrogen waste output, so I'll show you how we can do about it. So it's kind of nice that they boil it down to things that we can easily measure, and we've been working on it. But it's also water consumption. Are you drawing water? Are you having an impact on, are you drawing a significant volume of that water, a significant proportion of the water that is available? And in some region where aquaculture is very important, think Mekong Delta, in some region, the water drawn for shrimp farming, etc., is really quite significant. So this is an important consideration that never quite considered, right? So it's just water, we just pump it and release it. We should care about the nutrients. Well, the volume of water can have an impact, and as the climate is changing, that's a consideration that is probably going to become more and more important, at least to some part of the year. Now, interestingly, I was kind of surfing around and then finding kind of an example of effort, and there's one interesting one on feed additive, basically on trace minerals, company that provide trace mineral, get into detail. And they went through the different things, acidification and climate change and eutrophication and energy demand, etc. And they assess, the impact of this, of the different feed resource, putting the context on their trace minerals also, put in the context and see. And you can see different feed ingredients have different input, have different impact on things. So you'll be more concerned with climate change with one, and you'll be more concerned with eutrophication with the other one, in the way they're produced. So there are several of those efforts out there. There's a big database of life cycle analysis or impact done, the GLFI database is available. So there's increasing number of resources out there in order, to judge the quality or to do something about it and educate. Now, one of the major parameter, and the one that everybody's talking about, is greenhouse gas, right, emission, GHG, because these are what can impact the climate the most. This is something like maybe more visible. This is the thing that we're seeing, right, things changing quite fast, and we're suffering from heat, from drought, from extreme weather. So this is really it. Now we express this in carbon dioxide equivalent, but it doesn't only take into account carbon dioxide. It takes into account all molecules, gas and aerosol, that can contribute to the greenhouse gas warming, to climate change. So in this case, right, CO2 is the most abundant, but also methane. And then all these different kind of molecules, I can't pronounce the name even, right, that are contributing, that have a conversion. So there's calculator out there. You can calculate a carbon dioxide equivalent if you know the amount of the different gas that are produced. So different gas have different potencies, so they're converted into different carbon equivalent. Now, some gas, some aerosol will contribute to climate change or to warming, to global warming, I guess. And some of them may actually be cooling. As you put things in the atmosphere, some of these molecules, some of these particles can actually reflect light and then send back the light into space, send back the energy into space. So actually it's not just always about warming, it's the balance between the warming potential and the cooling potential of what is released. So it's a really quite things. That's something I kind of did not quite realize before. Now, by far and large, CO2 is the main greenhouse gas, followed by methane. But it's still pretty striking that all the other molecules, right, are also quite significant in volume there. Now, CO2 is the main greenhouse gas, but methane is a lot more potent than CO2. So a small amount of methane has as much impact or more impact than, right, the same amount of carbon dioxide. It's 16 times. I don't know exact number, don't remember the exact number, but it's something. And methane, right, is produced naturally under anaerobic conditions, right? The gas industry, the petroleum industry is releasing this. Natural gas largely made of methane. Ruminant animal, beef cattle especially, is releasing a lot of methane. But rice farming and shrimp farming are significant contributor of methane emission. Maybe shrimp kind of small, but it's still significant because we're flooding and we have anoxic layers in the bottom of the pond or in the rice field, and that contributes. So rice farming is one of the major emitters. So agriculture is a significant emitter. All right, so what do we do about it now? So I'll focus, right, so say, kind of give you kind of a basic information. What do we do about it? Well, you can't improve something that you cannot measure. So the very first step is to actually measure and be involved in effort that you measure. And that generally involves life cycle analyses. And I try to find information and kind of educate myself about it. And kind of my brain is exploding when I look at this because, right, it's you convert this in energy and this and that and this and CO2 and the like. It's really quite complicated. But basically, it's breaking down the production of an ingredient in all the different steps. From the seeds to planting those seeds, right, to fertilizing, watering and fertilizing these seeds, to harvesting them, to converting them, to separate them into different products, and to drying them or whatever the energy involved, and accounting for all the energy used, the CO2 equivalent produced, the waste output, the water use, etc. It can be, right, endless. You can break it down into endless, but there's experts out there that do this kind of work. Now, some industry is a little bit complicated because, right, you have a feedback loop. In this case, you have grains or something, and it's using poultry manure to fertilize. So you also have to consider, right, the poultry production as part of that. I find this a little bit kind of silly because you're not producing poultry in order to produce poultry manure. You're producing poultry meat, right? So the carbon footprint should be associated with the meat. But sometimes they look at it from an energy allocation, not a commercial, not a chemical allocation. And then the energy that ends up in the manure, right, is considered in your life cycle analysis. And there's different, right, because it's so complicated, there's different ways of doing it. So you can approach this completely differently. All this. When you're producing a product, it's also, right, it's about from start to finish to the end of the life of this product, and even to the recycling and what's going to happen. So that's the example of the poultry manure or the shrimp shell or something like this, right? It doesn't end at the product. It can also go further. It says, well, at the end product, the byproducts of it, and what happened to this, right, after the things has been produced and then shipped to the factory. So measuring, right, life cycle analyses, measuring carbon footprint is a very complicated process, but there's a number of effort out there. Like I said, the GFLI database developed by the Blanc Consulting, I believe, has been, right, a very good resource, but an incomplete resource for the carbon footprint of the different ingredients that we're using. Now we have to consider also that we manufacture the feed, so it's not just about the ingredients, but it's about the manufacturing process. We have to consider that we have to ship those feeds, so it's not just about the producing the feed, but about also distributing the feed. And then we also have to consider that it's not just about shipping the feed, but then how the feed are going to be used is going to impact the carbon footprint, right, of that feed or the overall process. I'll try to look into this. Now, how much aquaculture is contributing to, right, environmental impact? Well, it's a small impact. So it's been quantified in aquaculture. See, what, it's 0.49% of greenhouse gas emission. So very small impact, but everybody, given the, right, I think the dire situation in which we're gonna get in, any effort is meaningful. So even though we're a small contributor, right, it's like throwing a piece of paper. Well, everybody's throwing a piece of paper. More people are throwing a piece of paper on the street, trash on the street. Well, right, it starts with individual effort. So we as an industry should be a contributor to this. But of course, right, compared to the dairy cattle and especially the beef cattle industry, we're extremely small in terms of impact. And so if we want to make an effort, if government want to make an effort, right, they should be focusing on those industry and leave us alone. But, right, we should be good citizens and contribute to this effort. Now, different aquaculture species, you know this way better than everybody in this room knows this way better than I do. Every aquaculture production is different. Every species is different, and every species in every country is very different. So there's been these efforts to quantify the environmental footprint of different production. It comes out, right, and it comes very, very things. So you get not just by species, but also by country times species. So it's really, really complex. So if you want to calculate environmental footprint, one thing I think, or you care about this, I think what's important is to be really quite granular and say specific about this. You can just make just broad consideration. Aquaculture does this, and, right, shrimp does that, and tilapia does that. It's really quite specific to the specific condition, and even each farm is different, and every production lot is different. So we should get to that. So if we want to have an impact, we should go down to the lot level, to, right, to the cage or to the pond level of implication. A number of efforts have been led to quantify, right, for this. You can see this, the summary, and then specifically for shrimp. There's a study in 2017. And interestingly, it found that feed only represent 23% of the carbon footprint. Right? For shrimp, you have a lot of aerator, you're using a lot of input, you're changing water, you're pumping, right, etc. You have all kinds of things. You harvest your shrimp on ice, etc. So therefore, there are a lot more than feed to it. But this is for one farm, for one condition. In another farm, feed may represent a huge proportion of the carbon footprint, right? Depends on the technology used, depends on the level of intensity, depends on a wide variety of factors. And in this, Claude Boyd teams at Auburn University has been working on this, leading a several effort. And you can see that even within the shrimp industry, if you compare different countries, every country has different practice, different stocking density, different use of aerator, different surface, right, etc., different FCR, different yield. So therefore, right, you have to be really specific. That makes it interesting, right, because you have to go very specific case, and you can identify where you can have the most impact, right? It's not just a global industry, it's really quite specific where you can have impact. And I'm sure there's a lot of low-lying fruit out there. We can make great improvement by focusing, right, on specific areas of improvement. So what do we do? So first, we measure. We know our impact. So we're dealing with a certain client, a certain farm, a certain groups of clients. We can assess the impact, the release of greenhouse gas, the release of waste, etc., the acidification potential. Now what do we do? What's about making, right? So we're focusing on feed, about making the feed better, or the use of the feed better, so the feeding management or the production management practice. So what are the main driver of, right, GHG output, greenhouse gas emission, and waste output? The other things that we saw, nitrogen and phosphorus. I'll use nitrogen and phosphorus as my focus. Well, the intrinsic, right, characteristics of the ingredients. You're buying an ingredients. Well, this ingredients comes with a certain baggage. In the production of the ingredients, there was already some amount of greenhouse gas that were emitted in the production of the ingredients. So you start with that debt, that embodied or intrinsic that. That's a number one. Then you say, well, you're going to feed this, right? And we'll say, how much of those ingredients will it be needed, will you need in order to produce 1 kilogram of biomass? And then it depends on the composition of the feed, how well the feed formulators, the nutritionist is doing his job or her job, balancing the feed in order to make the feed more efficient. You can start with the same pool of ingredients and result in one good recipe and one bad recipe, right? And therefore, more or less environmental footprint. So focusing on the formulation, right, is really quite important. And then focusing on the digestibility of the ingredients affects the FCR, affects the efficiency of the animal, but also affects the amount of waste that is released in the environment, as we will see in a moment. So what you can do, well, first, I think you should focus on the ingredient. Selecting the ingredients, right, that gives you the best return, right, on investment in terms of reducing the environmental impact, reducing the greenhouse gas emission, reducing the waste output. You also want to rely on ingredients of consistent quality, right? So you don't have to redo the work all the time. It's not like just a random process. You want to make sure that you're using reliable ingredients that are, right, you can trust. And then you can start thinking, it says, well, now what can I do more, right? And then starting to think about feed additives and different solutions like this that will help you improve the environmental footprint, whether it's enzymes or probiotics, organic acids, or the like. You all know about those, right? Then you can look at those, not just from a health perspective or profit or FCR perspective, but also from a greenhouse gas reduction, a waste output in production. I think you're probably seeing this more and more from your feed additive suppliers. Some of you are in that field also. You're probably starting to promote, right, the solution also as a way to reduce environmental impact. Now, in terms of selection of ingredients, different ingredients have different carbon footprint, different greenhouse gas, right? Have had different impact on things. So selecting your ingredients will have big impact. You can see this kind of variation in terms of, right, level of greenhouse gas emission. Now you got a yellow bar there, and that's LUC, that's land use change. It takes into account the environmental damage that it was caused by converting a field or forest or something into a production, right, area for that. In some place, the field or the industry has already been established for a long time, so there's no land use change. It's not something important. There's no more change to the natural environment. But it's for some ingredients or some region, there's still significant changes in the use of the environment, the use of the land, that you need to take into account when you do this. So you'll see sometime with or without LUC, that means with or without the change in the natural habitat for producing that ingredient. So you can see a variation from oil palm to rapeseed to canola to whatever, fava bean, chickpeas, and it takes every type of grains is there, or oil seeds have an impact on that. Now, U.S. soy, right? So we're here at an event sponsored by U.S. soy. U.S. soy has a very low carbon footprint compared to, right, the other things. So the industry has carried out survey funded by the reputable, the companies that are doing these life cycle analyses, right, on a day-to-day basis, and identified that U.S. soy has a very low carbon footprint compared to Brazil, compared to Argentina, right? And then even lower than what is seen in many European countries and other things. Not that they're a very big competitor, but when you compare US soy with Argentina and Brazil, the main competitor here, right, you have significant advantage of using US soy, and we'll see this in a moment, right? If you take into account Brazilian soy that is been farmed on areas that was recently converted, the Amazonian forest, for example, converted to produce, to turn into soybean fields, you have huge impact on the climate because of this land use conversion. So not just about producing the soybean themselves and the energy and the fertilizer that you use, but also this associated environmental change to it. And because the U.S. industry has been established, right, for a very long time, there's no more land use change associated to it. Now you can see that soybean is even better, right, than some high protein source like blood meal. That kind of puzzle me sometime when you look at it, right? You say, well, you're using blood as a byproduct from the meat processing industry. It's kind of a waste stream, and yet the carbon footprint is higher because you need to dry those ingredients, and you also attribute the part of the energy of the product of the cow or the pigs or the chickens that you slaughter to that blood meal. So significant, non-negligible component, right? So it is, so when you look at greenhouse gas emissions, not always you say, well, I think it's going to be lower or higher. You really have to do the work. You really have to look specifically at each ingredient to do that. In poultry, it's been effort there. I like this figure, right, again by Blanc, and it demonstrates by using US soy, by replacing the ingredients and using more US soy, you could reduce by 25 to 30%. This is chicken, right? Probably not interesting for most of you, so we'll give you real aquaculture example in a few minutes. Now, it's not only about reducing greenhouse gas, it's also about reducing waste output. As you saw right from the feed ingredients risk tool, nitrogen and phosphorus are computed, the parameters that you should be targeting to reduce, and those are best addressed either by feed ingredient selection or by formulation, by nutritional, what you can call not just ingredient selection, but proper formulation. Optimizing the use of nitrogen, optimizing the use of phosphorus, reducing the level of these elements and stuff, like that. Oh, I think there should be a background, but actually it should be a fish farm behind or a floating cage behind. You can calculate waste output using a simple nutritional approach. My former boss, Young Cho, developed this in the late 1980s, early 1990s, did a lot of field work to validate the use of a nutritional approach to estimate waste output. And to make a long story short, it's better than going in a field and even sampling, because it's a lot more straightforward, a lot more robust than sampling water, in sampling 1 liter of water in millions and millions of liters of water that's flowing through this, right? One of the things, we talk about nitrogen and phosphorus, but one of the things I think is important and is overlooked in a lot of these environmental assessment effort is the solid waste. Fish produce manure, the same way pigs and chickens produce manure. That manure will settle in the bottom of a pond, create anostic conditions, create the growth of bacteria, promote the growth of bacteria, and some of which pathogenic, and cause potential some disease, or promote the incidence of disease, especially in shrimp culture. So we should pay more attention to this. So even though the certification scheme or the environmental impact scheme only focus about nitrogen, phosphorus, and GHG, we should also be focusing on solid waste. And again, it should be a background, but using a simple nutritional approach, we've developed the calculations and the insight. So whether you're growing tilapia, you're growing shrimp or pangasius, etc., we can estimate very accurately the solid waste, the nitrogenous waste, the phosphorus waste, solid and dissolved, the CO2 production associated by the crop of fish themselves, the oxygen consumption, etc. And it's extremely simple. You can do this in a spreadsheet or in a very simple program. It doesn't need to be complicated. If you know your feed and you have an idea of the farm performance, you can actually make some very good simulation. You don't need to waste a lot of time and money in this. Now, digestibility, is a key factor in selecting ingredients and doing this. So characterizing your ingredients is perhaps the most important things that you can do in order to improve, right, minimize the waste output, but also improve your ability to precision formulate your feed. There are variation in digestibility ingredients, and I'll talk about this in my second presentation. I'll focus on this. There are real difference in digestibility of ingredients across ingredients, but also among the same type of ingredient. Also, what determines the waste output, I was mentioning the solid waste output, is the total dietary fiber contained with this. The cellulose, hemicellulose, pectins, lignin that are contained within those ingredients are the main source of solid waste output associated with vegetable proteins and grains. Well, actually, they don't come, but these resources are not all the same. And things like soy will contain a lot less of these, right, potential source of solid waste than things like cottonseed meal, canola meal, wheat bran, things like that. So in order, right, to produce more environmentally sustainable feeds, environmentally friendly feed, often it's about simply selecting the more digestible nutrients, the more digestible ingredients, or the ingredients that contain the lesser amount of things that will generate the waste, the salt, right, the total dietary fiber, and the like. Right? So again, the solid waste is an important aspect of the calculation, and we should be striving to make our feed more digestible, more dense, right, in order to reduce the amount of waste associated to it. You want to then optimize your nutritional specification, tweak your level of your protein, amino acids, lipids, phosphorus, etc., in order to, right, make sure that the nutrients are efficiently retained by the animal and you're not over in excess. By formulating feed with higher nutritional density, right, in this case, you'll reduce FCR. It may not have any impact on cost, right, or it may cost you a little bit more, right, so the feed will be more expensive, but your FCR will go down. So in terms of production costs, it should be fairly neutral. But what you'll do is by improving the density of feed, by formulating, say, a tilapia at 33-34% protein, more fat, right, more digestible, you'll reduce your FCR and you'll greatly reduce the solid waste output associated to that. That's the real work we did in Indonesia. Very significant impact by simply changing, by promoting the use of better quality feeds in there. You can also make a big difference by phase feeding. There's something drives me a little bit crazy here in Southeast Asia is you have one feed for tilapia. But basically, as soon as the tilapia is able to eat a 2 milliliter pellet, then for the rest of his life, he's going to eat the same diet. What never happens in chickens or pig, it changed with size. We're changing pellet size. You go from 2 to 3 to 4 to 5 millimeter pellet. You can have different nutritional specification for each size. And therefore, better tailor your nutrient level, your phosphorus level to the need of the animal, and therefore have less waste output, because anything in excess of the need of the animal is going to be coming out as waste. You can do the same thing for amino acids, and we made it available on the IFFD with the support of USEC, right? We have this thing, and it seems to work. At least it's logical, and we need more feedback. But you can improve your nitrogen utilization by tailoring your amino acid composition, digestible amino acid composition to the need of the animal. Final improvement, you can make the best feed in the world. If it's not used properly, you're no further ahead, right? You say, oh, we know how to support a farmer. Well, we're doing a lot of survey in the industry, and I can tell you feed wastage and variation in FCR are huge in the industry, right? Yes, there are some very good farmers. They're getting good grow rate, very good grow rate, and very good FCR. But that's maybe 10% of the overall production, I would say. The average is less good than that, right? And just a calculation I did here, if the average farmer, the 50th percentile, became as good as the top farmer, the top 10 farmer, right? You could reduce feed usage by 200 kilograms. There's no changes in ingredients, in use of additive or genetics or feed manufacturing practice that can have an impact this big. 200 kilograms of feed saved like this per ton of biomass produced. So it is urgent, right, to improve the use of feed, not just about improving the feeds, but improving the feeding practice and how these feeds are used. And Dr. Sirat here is here. She's the expert in this, and looked in her paper and she did that calculation. If we could improve it by what? By 1%, I think you had by 0.1 unit, right? Here's globally the impact we could have. It'd be huge, right? So simply doing a better job at using the existing feed can already make a world of difference, a difference in the world. So why not, right, promote better utilization? So how can you improve also? Well, we can say you want to run simulation. My company, Wittaya, we've developed the tools in order to be able to do that, and we have a feed formulation tool that includes a carbon footprint calculator, but also FIFO, FFDRM, FFDRO, and things that ASC, BAP are asking. So you can now formulate on this. We have the database of ingredients for the carbon footprint we use from the GLFI, and we update it, we increase and improve it with the help of Richard Newton at Sterling and our own team. And to make a long story, so I had my nutritionist Flavia run simulation. By tweaking, by using the same ingredients and doing some tweaking, you can offset carbon release per ton of feed by about 14 kilogram in this case, by simply doing some slight tweaking. So instead of focusing only on price, you're focusing also on carbon footprint. You can have an impact without affecting the price all that much. You can also, right, reduce things in shrimp by about 15 kilograms, I guess, by simply tweaking, right? So while we're talking 15 out of 600 or 14 out of 400, so whatever, right? So it's a few percentage. Well, actually, the biggest impact you can have is to change your source of soy. If you move from Brazilian soy to US soy, right, then you can have much thing, 210 kilogram for tilapia feed in terms of this, right? So by tweaking ingredients, you can reduce by a few, right, dozen kilogram. By changing ingredients and using more sustainable, right, ingredient, you can have much bigger impact. So US soy, right, is one of the solutions to improve environmental sustainability of your feed, both in fish and in shrimp. The same type of reduction, 186 over, right, reduction. So very significant impact by simply changing your source of protein. So in conclusion, right, having a good handle on your footprint, on your waste output asset is the first step. You should be investing and understand where you are or where your clients are in order to make it this. You want to optimize your composition of your feed, whether on the ingredients, whether on the nutritional, on the formulation side. By selecting better ingredients, this is the most effective, right, way to reduce your environmental footprint kind of immediately and having significant impact. So US soy is one of the solution, right? But then finally also making sure that these feeds are well used, efficiently used on farm. That has the biggest impact also. Thank you very much for your attention, and I look forward to interacting.